So this question is about building a doubly linked list from a binary search tree. So we are given a binary search tree here. As we can see, this is the given binary search tree, and the idea is that we are going to utilize is for every node, every root node, we are going to create a circular linked list on each side. So there will be one on the left and one on the right, and then we will basically return the head of the circular linked lists to the root node, and then in the root node we are going to connect um, the the heads. So as we can see here in line number so first, in line number 8 we are basically saying what are the different nodes for building the binary tree, the binary search tree. We have a very basic class for building the binary search tree, as we can see here in starting from line number 84. In line number 93 we are basically inserting the values, and then we have for every node in the binary search tree we have a left and a right, as we can see in line number 86 and 87. So the left and the right, we are going to denote left as previous and right as next, because eventually it will form a linked list and not a tree. So once we have the root node for the binary search tree, we are passing that to the function get head, line number 18, and there we are calling the get circular list method to get the head of the circular linked list. Once we get the head in line number 20 and 21, we are basically breaking the circular linked list and returning just the head. So how do we generate the circular linked list? So as we can see, the root node, so we are going to point to the root node first, and that is going to get passed to line number 25, the circular linked list. So over there on line number 32, we are going to create the circular linked list from the left side. On line number 35, we are going to create the circular linked list from the right side. And then if we try to visualize like how the linked list is going to look at the end of the day, it's going to look like 1 is going to be connected to 2, and 2 will have a previous for 1, then we will have 3, and then we will have 4, then we will have 5, 6, 7, 8, and 9. And then we will also have 9 pointing next to 1, and previous of 1 is going to point to 9 because it's a circular linked list. So initially we are going to create a circular linked list for the left side. So if we think the left tree as a complete binary search tree on its own, in that case the linked list is should look something like 1, 2, 3, and 4. Right, just like this. And then on the right side we should have these ones. So the right one should look like 6, 7, 8, and 9. So these are the circular linked lists from each of these two sides, from the left side and from the right side. Now we need to build the circular list from the whole circular linked list from these two ones. So these two are going to generate this one. So we will see how we can do that. So what we will do is we are going to move this to the side and we will leave it there, and then we will also keep this one here. Right, so we know like this is how it's going to look like at the end, but if we try to understand how these two are going to get connected to 5 in here and then eventually form this one, we will get the gist of the basic idea. So as we can see here, so 5 should connect to the head of this, and we are saying the head is going to be the smallest element. So if we look at the left side, that is this side, the smallest element is going to be 1. This is the head, and then on the right side the smallest element is going to be this. So if we think from the left side, the linked list is created as 1, 2, 3, and 4. And when we want to place 5, it should look like 1, 2, 3, 4, and 5, right? So initially we had like this, but now we are saying that we are going to add 5 in here, right? So first we are going to connect this part. So when we have 5 in here, first we are going to connect 5 to 1, and the previous of 1 is going to be 5. So that's why we are saying in line number 52 we are saying connect left head to root. So our root is our root is 5, and we are saying if the left side, this whole left side is not null, in that case we are going to connect the left head, which is this dot previous, because we want the previous like we did here, right? So the previous of 1 should be 5. So that's how we are saying the previous should be 5. Okay, and we are saying in case the left head is null, that means this left tree here that we have, if this whole tree subtree doesn't exist, then in that case 5 should be connecting to the the le- the left head. So this uh, so this is basically the smallest element in the circular linked list on the right side. So 5 needs to connect to 6. So basically we want to say that 5 needs to be put in here, and what we are going to do in that case is we have 6, 7, 8, and 9. Since this is a circular linked list, we could have placed it here, but so that's what we are going to do. So initially we had 6, connecting to 7, 7 connecting to 8, to 9, and then 9 was pointing to 6, and then previous of 6 was 9. And now we are saying we are going to put 5 in here and say when 6 was pointing to 9, I am now going to point 6 to 5, and then the next for 5 would be 6. So that's why we are connecting in line number 52 the left head. So this is the head of either the right side or the head of the left side, which we are connecting to this root. Now once that is done, the next step that we need to do is we need to connect 5, which is basically the root, to the right side. So since we know that we have this right side here, so that is going, the head for that is this value. So we need to connect 5 to 6. So the connections should look like this. So at the end of the day, this thing should look like 1 is connecting to 2, 2 is connecting to 3, 3 is connecting to 4, and then 4 is connected to 5, and 5 is connected to 6, 6 is connected to 7, 7 is connected to 8, and 8 is connected to 9. So that's why we are saying in line number 59 we are connecting the root to the right head. So right now this is the root and the right head is 6, and we are saying that we want to connect those two. In case this right side is empty, in that case we want to connect 5 to the head of the left side. And initially we also checked in line number 44, we are saying we want to mark the tail as well. So from the left side, if we look, so let me clear up these things from here. So in this diagram, we are saying that on the left side we have this, right? And on the right side we have this. So whenever we have this right, so if we just consider the left subtree, in that case, the right child that we had 4 is going to be so if we want to think of this as a complete tree, then we were going to have 1 connected to 2, connected to 3, connected to 4, and then 4. How are we going to connect to 4 to 1? So for this part, this connection, we are going to mark the tail. So initially we are marking tail as this one, and then we are marking that in line number 44. We are saying like if the right head exists, in that case the previous for that right head should be, so initially we are saying the previous for 4, so right head dot previous, yep, that is the tail. And then at the end we are saying in line number 66 we are saying connecting this tail to this head. So then we are connecting the tail to the head like this. Yep, that's it.